All right, last time we studied this example where we had realized the power of uh, the streams, but before that we had uh, studied an example of collections where we had opened a collection, then filtered for transaction grocery, and then we had used a custom comparator, to sort as per the highest amount. And then we had put an iterator and then we had printed this. Now we replaced all these operations with stream, except the last part, which I had kept it purposely as it is for the demo. And what we did is that we did the operation first with the methods, the traditional methods given by the transactions. Now, today we are going to, have a more deeper look at the streams. So just to recap, what we did is that in this first method, let me uncomment this. Okay. In this method, this is a for loop. This is an advanced for loop. And what we had done is that for transaction T, where tran is an array, and we had tried to sense if the transaction is of type grocery, then we will add this to the list, right? And then what we had done is that then we had used a custom comparator here. In the custom comparator, we had done comparison of double, and we had return double. Let's try to format this. We are overriding a method which is int compare transaction T1, transaction T2, and we are returning the double when we compare the amount. Now, when we do this, so this operations we are doing explicitly using the methods given by collections. And then we are putting an iterator, and then we are able to get the transactions which are related only to grocery. We are not just collecting those transactions related to a grocery in a list. We are also sorting them. So for that, we had used collections.sort, the customized comparator. Operation 1, operation 2. Both of these operations we had replaced using streams. So what we did in the stream is we had taken the stream here and then we had filtered for transaction type grocery. We are using lambda here. Lambda is a function pointer. So for each element inside the stream, we are going to filter it. And if it is a transaction to grocery, then we are going to sort it in the reversed order. And this is the last is, the terminal operation, collect dot list. When you do a to list, these are all lazy, right? When you do a to list only, this thing starts happening. And then just for a demonstration, we can use a for each and print this, but I avoided that for each. And then we had printed this one. So far so good. Now we'll go a little deep inside this. So in this operation, we did filtering and we did sorting. But the final list, what we got is a transaction. Now let's repeat the same example wherein we want to achieve this in a different way. We don't want the list to be in transactions, right? So let's open another example. And we are doing everything same except intermediate operation. So here we have an example where we are going to do everything except here we're going to forget all this. This is all not needed. Let's keep the iteration, no issues, just for a demo. Now, what if I want, please pay attention of what I'm telling now. Instead of transaction, I want here as this as integer. And that to not permit integer, object integer. So now it says that you would see here, right? Cannot convert from list transaction to list integer, but I want to convert. How do I achieve this? So in streams, there is one more operation which helps you to do this. That is a map inside the stream. I'm not talking about the map collection. Please pay attention. I'm talking about map inside a stream. Once again, I repeat, I'm talking of map inside a stream. So what does the map take as an input and what output it can give? Uh, we are doing a filter, we sorted, and then we have to use map now, right? Now let's try to see how we can use map here. I would say this as dot map dot yum. Now see, there is a map here. There is a map to int and there is only a map function. And there is a map to long and there is a map to double. And what does this do? It gives me an output again as a stream of type R. So I'm going to use this map function. See, map takes argument as a function. Remember this. So when map takes argument as a function, that means I can take a method and pass to this directly. So right now I'm passing null, but I need to have a method where I can, pass this as an integer. So where will I get that method now? I need to have some method by which I can convert this entire list, which is of type transaction, into integer. And I'm using map. Map takes function as an input, and then it can convert this whole list of transaction into integer. Are you with me until now? So I'm going to put something like transaction get ID. Okay, now when I say transaction get ID, type mismatch cannot convert from list string to list integer. Change type of send grocery to list integers to string. No, we don't want string, we want an integer. That means there is a get ID method inside the transaction class which we were dealing with. So where is the transaction class which we were dealing with? This is the class. Is it having a method? Okay, let's try to return this as an integer instead of string. Now what does it say is that this is a string, so I need to make this as an integer. This also has to be an integer, right? So when you convert this into an integer, you have a method which is having integer. Let's go to our class here. And now you see the first argument, what I am passing, what does it tell? Is undefined, the string, double date. So let's try to do a quick fix and see what it suggests. Change the constructor integers to transaction string double. Create constructor. No, we don't want both of this. So we change the construction in the transaction.java class to take the first ID as integer. So let's try to give some ID as integer. So let's say this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 6. This is 1, 2, 3, 4, 7. Yes, transaction should be unique. And we can use a random generator and do that. But since the focus is on something else, let's not go into that. Okay, now we solve this problem. Now what it says is that I'm going to map this to an integer. Now I was trying to get a iterator. The iterator is going to tell me that no, I can't use for a sorted groceries transaction, I can't use it. So I'll try to use an integer. Now if I run this program, what happens? Fingers crossed, will it work, not work? Let's try. Okay, unresolved example. Line number 11, there is an issue. What is the issue? So let's format this. And then formatting helps you to give clarity of what is there in your program and then, resolve the issues. So always remember as practice, indentation and formatting are very important. So right click, source, correct indentation, and then format. Now it looks pretty neat, right? You do understand the operations. So I'm having a transaction array here. First I'm declaring transactions, different transactions. I'm invoking them. Then I have a list. Then I have the transactions. Then I'm doing the iteration here. I'm going to leave a line purposely blank for clarity. Now let's see. Let's run this. Realize what was the issue. Yes, we got this. Now size of the list is 3. Now it is just printing the transactions, which is having a integer list, and it's all printing as per the size. So let's try to find out what exactly we did here. If you see this diagram, let's expand this diagram into more legible means. Now, if you see this diagram, the first operation, what we did is that we made a stream of transactions, right? Here, we made a stream of transactions. This is a parallel stream. Let's keep this as ordinary stream, not parallel stream, for clarity's sake. Transaction dot yes t stream. So this is a stream transaction. Then what we did is we did a filter operation, which is here. And then what we did is we did sorting to make sure that the amount, whatever we get, is the first comes the highest amount in the descending order. And then the operation, what we did after that is mapping. Why did we do this operation of mapping? What is the purpose? The purpose is to get list of integers instead of list of transactions. So let's remove this comment for now. And then let's come back here. So this is mapping to make a stream of integers. And then we collected this in a list. So we got all the identifiers of this transactions, which is sorted in a integer list. So now let's go back one more deep. So in the filter, what we did is we called a method to get the type, and then we took only those which are groceries, and then for sorting, we sorted as per the amount we are calling transaction. So note this, what is this 4 columns and get value. So even the compare, even the sorting, what it is doing is it is taking the compare operation, comparing operation, which is in turn, calling a method and reversing it. The map is also taking a function as an argument, and then it is mapping to a stream integers. So this method gets you only the identifiers. It's mapped, and as soon as you map it, you get a stream of integers, and then you collect that stream of integers inside the list. So what we get is a list of integers. This is about the first example on streams, and we are going to see some more examples. If you like this video, please hit the subscribe button. Happy Java coding. See you in the next episode of streams.